So it's shorter than your study guide. Okay, problem number 9. We have 8 to the w plus 7 equals 27. So if I'm trying to solve this, we are solving for our w. So we have to get this term by itself. So we'll start out subtracting the 7. Then we check, can we get a common base? No. You cannot tell me like log base 8 of 20 and put that in your calculator. I want you to do it the strategies we've done so that any calculator will be able to do it, not just if you know how to get to certain functions within this one. So what we do is we add a log to each side. And we're doing log base 10 because that is a button that every calculator has. And then what happens? So we have w times the log of 8 equals the log of 20. So we divide log 20 divided by log 8. When you type that in, make sure you close those parentheses and you get 1.4406. All right. Is that one okay? All right, number 12. We have log base 3 of x squared minus log base 3 of 7 equals 12. If we are subtracting our logs, how do we combine them? Divide. So we have log base 3 of x squared over 7 equals 12. Okay, so this is a problem that starts with a log. Since it's only on one side, do I just want to add a log to each side? No, because that would give me 2 logs over here and it gets even more complicated. So when it's only on one side, we change it to exponential form. So it becomes 3 to the 12th power equals x squared over 7. So then if you're trying to get x by itself, you would multiply the 7. And this is a huge number. Sorry, that's what happens when I make up problems. To get rid of a square, we square root. With that, you do plus and minus. But can we have a negative for the x here? No, so it'll just be a positive, and it comes out to be 1,928.7527, approximately. All right. Number 13. So we have log of 7x minus 12 equals 2 log x. Can you just distribute that log? No. Properties of logs, when we are expanding and condensing, we can only break apart multiplication and division. But what I could do is take this 2 and turn it into an exponent. Then I have 1 log on each side, so what do? Drop the logs. So then it's quadratic, so we set it equal to 0, so I subtract over my 7x, add over my 12. What multiplies to 12 and adds to negative 7? So if we set those equal to 0, we get positive 3 and positive 4. We do need to check on this. So if I put in a 3, that's positive. If I put in a 4, it's positive. So this one does in fact have 2 answers. All right. 14. Okay, a square root can be written as what power? 1/2. Just as a side note, what if I had said like 3 to the x plus 5 equals 1/3? What would you do with that? What would you do with a 1/3? 3 to the negative 1. So just a hint, you know, that might show up on your test. We know negative exponents flip it, so if you need to flip it, that's fine. Radicals we can change into fractions. Then this one has the same base on each side, so we could drop that base Quadratics we set equal to 0. But what makes this problem hard? The fractions. So let's get rid of them. Let's take everything times 2. So we get 2x squared plus x minus 1 equals 0. So then we could factor using slip and slide. So multiply -2 and add to +1. Be +2 and -1, but what do you have to remember to do? So we get x plus 1 and 2x minus 1. So then we set each of those to 0. We get -1 and +1. What do I need to make sure to do at this point? Check them. But I don't have logs to begin with, so it should all work. Okay, it's the problems that start with logs that we have to be worried. On this one, they should work, but you could always plug them in your calculator and confirm that. We did not ask about 15. Do you want me to work it? That's just a common base question. Let's go over 16. Okay. So what would I do here? Is common base an option? No, we cannot get a common base, so we add our logs. And when you add the log, the benefit is the exponent comes down in front, and I'm going to write that in parentheses. So then we can distribute. So we get x log 5 plus 2 log 5 equals x log 7 minus 2 log 7. Now what? Okay, we need everything with an x on one side and everything without it on the other. So we get x log 5 minus x log 7 equals -2 log 7 minus 2 log 5. Yours could look a little bit different here if you took things to the opposite sides, just everything would be off by a negative, which is fine. You'll get the same answer in the end. We can't actually combine these, so what can we do? So we get log 5 minus log 7. And then we divide. These are the problems for probably the highest potential for error when you put them in your calculator, so please write down what you're plugging in the calculator. Don't be one of those people that can see up here what it's supposed to be and skips all the work and then plugs something in wrong and loses all the points. Okay, show me your work. We know every time we push a log button it opens the parentheses, so you have to close it, and you're also going to need parentheses around the entire numerator and the entire denominator. And so when you plug all that in, it should come out to be a 21.1331. And we can always check those just by plugging them back in to the original and seeing if it works. All right. Is that okay? Okay, what else on this page, 17 through 20? What else do we need?
I have a question about 18.
Okay.
Is it okay if I just put that as -7 plus square root of 41?
Yes, that is correct. Any of these you want me to work out? You guys did okay on 17 where you had to get a common base and combine them? There'll be one like that on your test with those multiple terms over there. Okay, so let's focus on the back 2 pages, and then if we have extra time, we'll come back and work more of what we skipped. So 21. This was just an interest problem. You'll have one of these on the test. It will be similar in that I'll put the two formula options afterwards. So when do you use which formula? Like, how do I know which one?
The small one when it's a continuous.
Yes. If I say it's compounding continuously, that's when you use the formula with the E in it. Otherwise, we're relying on the first formula. So if we plug this in, we're using this formula. All right, it says find the present value, so I don't know my P, of 15,000, so that has to be my A. Invested at 2.34%, so what do we use for the rate? Compounded monthly, so N would be for a period of 42 months. When you do your time, it has to be in years. So how would I change 42 months into years? And you get, if I had said compounded for like 42 quarters, what would you do? Divide it by 4. So make sure you convert that time into years. And so then if we just plug in, we have 15,000 equals P, 1 plus 0.0234 over 12 to the 12 times 3.5 power. So to get P by itself, we are just going to divide all of that over. And you can just plug that whole thing into your calculator at once. And it is money, so we'll round to 2 decimal places, so we get $13,821.56. Is that okay? $22. What is the easiest way to decide if something is one-to-one? Look at a graph. Grab a graphing calculator real quick and put this in. So 2x plus 1 squared minus 6. If you're using the graph on the test, please draw me a picture of the graph. It doesn't have to be real precise, just a rough sketch, so I know what you are basing your answer off of. And so you get something like this, right? Is that one-to-one? One-to-one means it passes the horizontal line test. So this fails the horizontal line test, which means it is not one-to-one. It means we can't find an inverse of it. We had to have one-to-one functions to find the inverses. All right, then the next two questions are actually finding the inverses. These are worth a lot of points, probably 6-7 points apiece. So make sure you know how to do this. That's why I put a couple on here for you. What is the first step? And then what do we do? Okay, now we want to get it back into function form, so we need a y equals. So we're solving for y. So if you want to get rid of the fraction, you multiply by the denominator. So you get xy plus 2x equals 1. You can subtract over the 2x and divide by x. So, what do we write to represent inverse? F to the negative 1. That means F inverse. So inverse is just flip x and y. So we flip our x and y, and then we get it back in function form, so we have to get the y by itself. Is everybody okay with that? Then I have you do domains and ranges. And we know that the domain of the function is always equal to the range of the inverse, right? The range of the function is equal to the domain of the inverse. So for my domain of the function, if I look at the original, we know in a fraction the bottom can't be 0, so x can't be negative 2. Negative infinity, negative 2, negative 2 to infinity. Then we can look at the inverse. What can x not be here? So this one will be negative infinity to 0, union 0 to infinity. Is everybody okay on this kind of problem? So we had a question on 24 anyway. We'll go ahead and work through it. I'm good to practice these. So same thing. So instead of f of x, we write y. We have to switch x and y. Since I have two x's, this turns into two y's. I'm trying to solve for x, so I'm going to multiply over my y minus 1. So we get xy minus x equals y plus 2. What are we solving for here? What variable am I trying to get by itself? Y. So I'm going to get my y's on one side and everything without on the other. I get xy minus y equals 2 plus x. Now I can't add these, the kind of same strategy we used with the logs. What can you do? So then to get y by itself, we divide. So we get 2 plus x over x minus 1. The inverse, 2 plus x over x minus 1. We know the domain of the function is equal to the range of the inverse. If I look at the original function, x cannot be 1. So negative infinity to 1, union 1 to infinity. The range of the function is the same as the domain in the inverse. So if I look at my inverse, x can't be 1. And these are actually the same. This original function was already symmetric across the line y equals x, so it is its own inverse. Doesn't happen very often, but every now and then. Is that one okay? Is this helping you guys? Are we getting your questions answered? Okay. So then we got into the exponentials. If you remember what you're doing, these are really easy to graph. When I say f of x equals 2 to the x, what do we do? T-chart. What 3 points do we plug in? Okay. If you put in negative 1, 2 to the negative 1, 2 to the 0, 2 to the first. Okay. So I have negative 1, positive 1/2, 1 0 or 0 1, and 1 2. When you graph these, you can always use your calculator to confirm your graph, but I will check that you have those 3 exact points. It doesn't ever hit the x-axis, that's just the horizontal asymptote there. What's the domain then? And the range? Next one. So again, still exponential. 1/2 to the negative 1. 1/2 to the 0, and 1/2 to the first is 1/2. So negative 1 2, 0 1, 1 1/2. So it's the same thing, it just got split. Domain? Yep, always. And the range is still 0 to infinity. Parenthesis on the 0, we don't ever hit the x-axis, we're just getting closer to it. Alright, so we could graph an exponential. Let's talk about graphing the logs. So when I said h of x equals log base 2 of x, anytime I asked you to graph a log, what did we do? We went to exponential. H of x is the same as y, so that means 2 to the y equals x. So then this is the exact same thing, except my exponent is y, so we're plugging in these numbers for the y. So 2 to the negative 1 is 1/2, 2 to the 0 is 1, and 2 to the first is 2. If I plot these, we get 1/2, negative 1, 1, 0, 2, 1. So the exponential had a horizontal asymptote, the log has a vertical one. So the domain here, just like exponentials we said are inverses, so the domain and range flip. The domain, this graph starts at 0 and goes forever. Range, it hits everything. And the last one. Change to exponential. This means 1/2 to the y power equals x. So you plug in for the y. 1/2 to the negative 1 is 2. 1/2 to the 0 is 1, and 1/2 to the first is 1/2. So 2, negative 1, 1, 0, 1/2. And domain and range don't change. Is that okay? All right, expanding and condensing. So you will definitely have a few of these on your test. So the first one. So we have x squared, y to the 5th, square root of z, over a to the 4th, p to the 7th. All right, when you're expanding, you are breaking apart all multiplication and division. Everything on the top will be positive, everything on the bottom gets subtracted off. So how many logs am I going to write here? 5. We have to have one for the x, one for the y, one for the z, one for the a, and one for the p. So we will have 5 logs here. So we have log base 5 of x. What do I do with the square? Put it in front. These are all on top, so plus log base 5 of y. We take that 5th power to the front. Okay, I'll probably do this to you on the test. If I have a square root, what kind of power is that? That's a 1/2. So this would be a 1/2 log base 5 of z. Okay, both of these are on the bottom, so both of these will be subtracted off. So minus log base 5 of a, so the 4 comes in front, minus 7 log base 5 of p. Make sure you're writing your base on all of those. Make sure if you have a radical, you go ahead and turn it into an exponent, and also watch if you have more than one thing on the bottom, subtract all of those off. Is that one okay? All right, the other way, condensing. Okay, let's start with coefficients. We know that any coefficient would turn into an exponent. So that would be a cubed. This would be a fourth. This would be a fifth. Our goal is to condense these into a single log. So if it was positive, it's going to go on top. This one was subtracted, so it goes on the bottom. This one's subtracted, so my x is on the bottom. This one's added, so the y goes on top. So you can write it like this. If you flip the order, that's fine as well. If you wrote y to the fifth times x minus 1 cubed over x times x plus 3 to the fourth, that's fine. So expanding and condensing, we'll have a couple of those. Are we good with that? Mm-hmm. Last question.
Oh, sorry. I just cheated.
Okay. So this is actually a very simple question. If you think back to all of our log problems, every time we have a log, I tell you to check your answer and make sure that what is true. The argument has to be positive. So when I'm asking you to find the domain of this, we know that the argument, the 2x plus 3, has to be positive, so bigger than 0. So then we just solve this. Subtract our 3, divide by 2, so x has to be greater than negative 3 halves. How would I want you to write that, though? Interval notation. Negative 3 halves to positive infinity for the domain. Right, so if I ask you for the domain of a log, you could get it by doing a graph and transformations, but that's really more work than we need. Just like when we solve the equations, just take your argument greater than 0 and write an interval at the end. Okay, we have some time. Are there any problems, first of all, that I did not work out and you need me to? Okay, yes.
Could you do a problem where it's compound continuously?
Yes. So if I said, find the future value of $300 compounded continuously at 1.35%. So it says that continuously, so that's A equals PE to the RT. If I want you to find the future value value is what variable? A, so we're finding A. So what's the 300? That's our present value, or the principal. E, what's my rate? I might left off something. Let's say for 11 quarters. What would you do for your time? We have to do 11 divided by 4, which is 2.75. So then we just plug this in. Remember the E button is above the natural log, so if you push second the natural log. You get $311 and make sure you round up if necessary, so 35 cents. Anything else specific, or do you just want me to make up some problems? Do I need to do it now?
a logarithm where you have to divide it over, but it's like a log plus another log. Do you keep it as a positive log, or do you have to make it negative because you're dividing it?
You have, before you divide, you have to put those together. Or a lot of times we factor out an x and we just have that whole parenthesis. So you don't change anything about it except dividing it over. So the parenthesis itself doesn't change. All right, I'm gonna throw some problems up here for you guys. So extra practice, types of questions I might ask. Really hope these work out. I know you're not done, but we don't have a ton of time left, so I want to kind of start talking through these. What'd you do on the first one? Anytime there's a log on one side, go to exponential, so it would be 7 to the 3x minus 2 power equals 49. So what could you do now? Yeah, 49 is 7 squared. So that means 3x minus 2 equals 2. So 3x equals 4 and x is 4/3. B. We can get a common base. 9 is 3 to the second. We have the 3 to the x squared. 81 is 3 to the 4th squared. So we have 3 to the 2x times 3 to the x squared equals 3 to the 8th. Before you drop that base, you have to combine these. When you multiply, what do you do with your exponents? Add. So then we have x squared plus 2x equals 8. So subtract over the 8. So what multiplies to -8 and adds to +2? We're going to get x to be a -4 and a +2. All right. Next one, is common base an option? No. So what do? We add logs with e's. We like ln because a natural log of e just cancels. So we get -6x plus 2 equals the natural log of 15. So then we can subtract over the 2, divide by -6. When you go to plug this in, you have to have a parenthesis here and around your 15. So we get the natural log . negative 0.1180. Last problem. If these logs are added, how do you put them together? Multiply the arguments. So x minus 3 times x would be x squared minus 3x. Then log on one side, we change to exponential. What if it were a log on both sides? You would just drop the logs. Okay. So that's a 4. If we subtract that over, multiply a negative 4 and add to negative 3, be negative 4 and positive 1. Set those equal to 0 and we get 4 and negative 1. But since the problem started with logs, we know that the domain, these have to be positive, so only the only the 4 will work. So, test tomorrow. If you have any issues with coming in, let me know, or if you have any questions in the meantime, pop in, shoot me an email, whatever, so I can make sure your questions are answered.